Hi and welcome to this video on derivatives of logarithmic functions. For these derivatives there are four formulae which you have to know. I've listed them here and we'll go through each of them in turn. So for the first formula, if we have something like y equals natural log of x, then the derivative is 1 over x. For the second formula, if we have something like y equals natural log of 3x squared minus 1, then differentiating we get 1 over 3x squared minus 1, and then we multiply that by differentiating x, which is 2 times 3 is 6x. Using the third formula, if we have something like y equals log 7x, then y prime 1 over, so the x, and then the natural log of 7. For this one, the final one, if we have y equals log 8 x to the 1/3, differentiating we get, bring the 1/3 down, and then we get log 8x to the minus 2/3, and then we multiply by 1 over x. Okay, let's go over some quick examples, derivatives of logarithmic functions. Y equals natural log 6x to the power 4. So y, differentiating y prime. So 1 over 6x to the power 4 multiplied by 24x cubed. If we rearrange, this becomes 24x cubed 6x to the power 4, which equals 4 over x, and that is your answer. 2. Y equals natural log of 4x to the minus 3. Differentiating, we get 1 over 4x to the minus 3 multiplied by, so minus 3 times 4 is minus 12, and then x to the minus 4. Rearranging, we get 12x to the minus 4, minus 4x to the minus 3, these cancel, minus 4 minus minus 3, we get minus 1, so those are the powers, so the answer would be 3 over x. minus. Y equals natural log cos 4x. So differentiating, we get 1 over cos 4x, and then we differentiate what's in the brackets, we get minus 4 sine 4x. Rearranging that and tidying up, sine over cos is tangent, so the answer is minus 4 tan 4x. Another example, if we have y equals natural log x squared plus 10, y prime equals 1 over x squared plus 10, and we multiply that by 2x, so that's 2x all over x squared plus 10. Square root of x, natural log of x. So here we're multiplying two functions together, so this is the product rule. So we have differentiating that, x to the half, and we differentiate becomes half x to the minus half. Then we differentiate, we leave the natural log of x alone. So we differentiate the first, leave the second alone, so that's natural log of x, plus, then we leave the first alone, which is x to the half, and then we differentiate natural log of x, which is 1 over x. And that is your answer. If we have natural log, let's use something different this time, a quotient. So we have 3x plus 1 cubed over 4x minus 1 to the power 4. So using log laws, we can split this up. When we divide, we minus, so we end up with natural log 3x plus 1 cubed minus the natural log of 4x minus 1 to the power 4. Now, using the laws of logarithms again, we can bring the 3 to the other side. So this becomes 3 natural log 3x plus 1 minus 4 natural log 4x minus 1. So we just brought the 4 down, brought the 3 down. Now the 3 and the 4 are constants, so when we differentiate f prime of x, we get 3. When we differentiate natural log of 3x plus 1, we get 1. over 3x plus 1, and then we differentiate what's in the brackets, we're left with 3, minus 4 is a constant, stays where it is. Natural log of 4x plus 1, when we differentiate we get 1 over 4x minus 1, and then we multiply that by differentiating what's in the bracket, which is 4. And that is your answer. Okay, let's go on to logarithmic differentiation. So if we're given something to differentiate like y equals x to the power 6, we know that becomes 6x to the power 5. Bring the 6 down, minus 1 from the power. If we have y equals e to the x, it remains e to the x. What happens if we have y to the power 5 to the power x? What do we do then? So for this we need another method, and we do what's called taking logs on both sides, and for this we need to know some log laws, and especially this last one here. Okay, so where we have especially a variable to the power of a variable, then we need to use logarithmic differentiation. So how do we go about this? So let's do that. Y equals 5 to the power x. Take logs on both sides. So that's natural log of y equals natural log 5x. Now what we do is we bring the x down using log laws, this one in particular. So this becomes natural log of y equals x natural log of 5. Now we use implicit differentiation. And in implicit differentiation, when we differentiate natural log of y, we get 1 over y dy dx equals natural log of 5x. Now the natural log of 5 is a constant, so when we differentiate, another way of writing this is y prime over y. When we differentiate, we get the constant natural log of 5 and when we differentiate the x, we get 1, which we can leave out. So y prime equals y, taking the y to the other side, natural log of 5. Now y equals 5 to the power x, so when we replace that, y prime equals 5 to the power x natural log of 5. And that is our answer. Okay, let's quickly do some examples of logarithmic differentiation and taking logs on both sides. Y equals x to the power x. Taking logs on both sides, natural log of y, natural log of x to the power x. Using our log laws, bring the x down. And we get x, natural log of x. Here, when we differentiate, we have to use product rule. So y prime over y, the first multiplied by differentiating the second, which is natural log of x becomes 1 of x, plus the second, which is natural log of x, times the first, which is 1. So y prime equals y 1 plus natural log of x. When we multiply the x by the 1 over x, we get 1. When we're just left with 1, so this becomes 1 plus natural log of x. Okay? Now y is x to the power x, so y prime becomes x to the power x 1 plus natural log of x, and that is our answer. Y equals natural log of x to the power x. So taking logs both sides, natural log of y is natural log of x. Using our log laws, so bring the x down, so the natural log of y is x times then natural log of x. Here we have product rule when we differentiate. Do some implicit differentiation. Okay, so in the product rule we have the first x times the differential, or differentiating the natural log of x, the natural log of x. So the natural log of x is 1 over ln x times 1 over x. So if you don't understand that, let's just do it as an aside. So natural log of x dy by dx is 1 over natural log of x, which is this, multiplied by 1 over x, which is inside the bracket. And then plus, we leave the natural log and the natural log of x alone, and multiply it by the derivative of x, which is 1. So our answer then, y prime is y, 1 over natural log of x plus natural log of x. And that is our answer. Okay, let's do something slightly harder. Y equals x squared minus x, 2x plus 1. So taking logs on both sides, we get natural log of y, natural log of x squared minus x, 2x plus 1. Bracket around that. Now when we bring the 2x down, we get 2x times the natural log of x squared minus x. Here we can factorize this being the difference of, no, not the difference of 2 squared. We can factor out the x, in this case x squared minus x, so we're left with, this becomes x minus 1. Distributing the 2x plus 1, we get 2x plus 1 times the natural log of x and then 2x plus 1 natural log of x minus 1. Here we need to use the product rule. And here, product rule again. So y prime over y, 2x plus 1 over x, which is the first multiplied by the derivative of the second plus 2 natural log of x, which is the derivative of the second multiplied by the first plus 2x plus 1 x minus 1 plus 2 natural log of x minus 1. So when we apply the product rules in these cases, those are the answers that we get. So y prime equals y multiplied by the natural log of x squared minus x all squared plus 2x plus 1 multiplied by 2x minus 1 over x squared minus x. So, and that is our answer.